Hello, everyone. Hope you all had a good weekend. So today we get to learn about the joy of UML diagrams, which I prefaced with saying is not a joy at all, but we'll get to that before we get started. I have a couple of announcements, one good news and one very important. It's not really good or bad news, just something for informative information. So the good news is for the first assignment, everybody got it in, and there were, I think, a couple of clarifying points, but for the most part, everybody did everything they should have done. Everybody got 5 out of 5 in the class, which is a good start. Okay, if everybody continues that pace and gets 5 out of 5 on every remaining assignment of the class, I will be very happy with the semester, and my joy extends to all things joyful. So that's all. So thank you very much for that. As far as some stuff on Brightspace, I wanted to make you aware of. Over the weekend, I was productive. I don't like being productive on the weekends because weekends are meant to relax. I know I'm talking to Truman students, and you probably are saying, Dr. Barnes, I work like 13 hours on the weekends. So I try my best, but I did work over the weekend. And one of the things that I put together is I put together the AI research project instructions, which I said I was going to be developing. They are now up and available. I'm not going to walk through each of the details of the project or instructions. It's on Brightspace under course materials. You can look through the detailed instructions if you wish. I would like to make you aware of a few things that you probably need to know about as far as the research project goes. I did make a slight change to the nomenclature that was in the syllabus. There's actually 3 deliverables in this particular assignment. One of these is kind of just an update on the project. It's going to be due right before the end of, right before we break for fall break. Then there will actually be the deliverable, which will be a report and your queries, which I'll talk about here in just a second. And then you'll have your presentation, and we'll talk about the nature of that here shortly. So I want to make sure everybody knows this is on Brightspace. You've got your schedule. The problem is that Brightspace's notification schedule is like 2 days before something is due. If you wait 2 days before this, you probably are going to be rushed. So I want to make sure everybody has it on their calendar. So first of all, I have updated the syllabus with all of these dates on the syllabus. So you can actually look on the syllabus to see what I'm desired to do. But I thought maybe it might be helpful for me to update everybody just where they're at right now. So if you go to week 8, you'll notice there wasn't a week 8 before. There's actually AI research project deliverable. All this is going to say is I've had a few AI research sessions before this. It's just really straightforward to the point. It's a 15 points. You're just going to give me your research question and a summary of what it is that you want to do, 1 to 2 pages of your idea and why it's interesting. This is very open-ended. You don't need to really worry yourself too much about the criteria. I do give you some guidelines within the research project instructions themselves. It does need to be relevant to the point. If you're just kind of like, okay, I really like video games and I want to do a research project on how AI influences video game playing. I mean, I love video games too. And if you can make an argument to why it's relevant to business and accounting, then I'll be like, yeah, go for it. Okay. But it can't just be something that you just find entertaining. It does need to have some sort of relevance to what you're doing here at Truman State. So that's something to consider. So that's going to be right before we go on spring break. We're not actually going to be, I shouldn't say that. We're in all likelihood not going to be meeting as a class on March 7th. I leave that day open, and usually we don't meet as a class on that date, but that assignment is due on that date. So just keep that in mind. Next deliverable, I believe I made it for week 13. Mostly because week 14, we've got an exam coming up. So this is going to be the actual report itself. A few things you need to know about this. This is not going to be a long report. First of all, I despise reading long reports. I have very short attention span. I already have to read enough research papers as it is just for research purposes. So you're going to keep it short and to the point, and you're going to give me your research paper about what it is you learned from your experience. You also need to have a document containing the script of all your AI queries. So as we're doing the AI queries in class, as we're working with AI tools, at the end of class, you'll want to copy and save all of that. You put that into a document as well, just so I can see what it is you did. You can edit it if you want. Like if you ask silly questions that are not relevant to your work that you do in research, that's fine. You can edit that out. There's no need to. I'm probably not going to scrutinize it in detail. Just mostly kind of evaluate what it is that you did and how it relates to the research. So that's the second deliverable. That's 35 points. And the final deliverable is actually a presentation. There's no real instructions on this. This is actually detailed instructions, but this will be during week 15 during the week. We have 24 people enrolled in the class, so there'll be 8 presentations each day. And I've actually set a research presentation date selection spreadsheet up here. So you'll notice there are 8 places for names, so you can sign up for the names now if you want to. You can wait until later on. Doesn't really matter. I just made it available. I do want to make a note, and I want to make sure everybody's aware. I've underlined it, and it's going to be something that I'm going to frown at if I get a notification on this. You have to sign in to Google, but you have to sign into Google using your Truman State account. Okay. If I get a notification email saying somebody in my class has requested access to the document, and I see it's because they use their personal account, I'll probably just sigh, and then I'll say, I'm going to send you an email, a very polite email saying you have to use your Truman State account in, but I'm going to shake my head at you. You don't want me shaking your head at you. Okay. So please make sure you sign in using your Truman State account. So that's going to be a selection of Monday, Wednesday, Friday. Really quick, just to note for what the presentations are going to look like. It's a very non-traditional presentation, and you probably can guess that from the fact that we're going to be doing 8 presentations in a 50-minute class session. The presentations are like 3 minutes, and they're based on something called the 3-minute thesis competition, which is a graduate competition, but I thought it would be appropriate for this. You make 1 slide, and you just basically summarize in an elevator type pitch of what you did with your results, okay? So this is not meant to be stressful or something that you have to put a whole lot of effort into. You have to put some effort into it. If you like put together the slide in 5 minutes and call it good, that's probably not sufficient, but it's not going to be hours and hours on end. Also, one thing that I note in the instructions, keep in mind that we're going to be doing this over the course of the semester. So think about this over the course of the semester as we're doing this and try to develop and articulate ideas as we're moving through. I'll be encouraging you all to continue brainstorming as we work through some of these ideas and work through some of our knowledge and learning in AI. That's going to be kind of the goal here. Ultimately, I want you to just come out with this, answering your question that you had, that you might have developed over the course of the semester and trying to come up with some answers for it. Or if you don't come up with the answers for it, saying why it is you couldn't develop an answer. Whatever it is, it's going to be kind of the purest form of learning. It's going to be something that you want to learn about, not necessarily what I want you to learn about. All right, if there are any questions on that, after you've read through the documents, feel free to shoot me an email. Again, I think I've documented, articulated everything. All the assignments are listed there, the reminders, but again, I encourage you to make sure you be proactive on this, and we'll have some reminders as we do these class sessions. We're having our first AI class session on Friday, so that'll be plenty of reminders for that. All right, today, as promised, we're talking about UML diagrams and data modeling. So let's go and get started. Now, I do want to say, the one thing that I've always noticed, and I've already articulated in class, is that people tend to get really, really freaked out about UML diagrams. I do not think they're particularly difficult, but it's one of those things that people have a natural disinterest in. You may have to force yourself for the exam to say, all right, I'm going to take this seriously, but if you blow it off just because you don't like it, it will come back to bite you because it is a big part of the first exam. There will absolutely be questions on this, including problems associated with this. This is one of those areas that people tend to struggle with on their first exam when they're studying stuff. So I'm not going to give you the most difficult versions of this. Just for background, several years ago, I did an online conference during the pandemic. It was talking about how we actually do UML diagrams. This was what we were supposed to actually create. They actually gave us a homework assignment and they say, all right, we want you to create this diagram right here. All right, not that right there, but this is what it looked like. And if everybody's looking at this like this is a nightmare, Dr. Barnes, I would never want to learn this. The good news is that this is nowhere close to what we're going to be doing. The stuff we're going to be learning will be much more straightforward. We're going to kind of talk about the conceptual information that kind of underpins this diagram, but we're going to have a lot more organization, a lot more simplicity. It will still be powerful. But I want you to note that if you're worried about the complexity and say that the stuff that I'm teaching you is too complex, it can be a lot worse, and this is a lot worse right up here. This is the extreme version of UML learning right here. So remember from last week we talked about business process models, okay? And business process models, they kind of flow from activity models, which is business process model notation. But we have other ways of characterizing business process models, and this is going to be our second one, which are going to be structure models. All right. So we're in chapter 3. We're talking about it. By the way, just a reminder. We are in the point in the semester now that your homework is going to be due on Wednesday rather than Friday. So what we're completing today, you have homework that will be due on Wednesday. You'll have to complete that, which we will talk about on Wednesday. Just a reminder in case I forget to say it at the end of class. But so we're going to be talking about structure models today. And structure models describe the entities or things in the domain of interest. Now that seems really, really weird language, say entities or things. Why did I use those two terms? It's because when we start talking about classes, classes can be representative of entities, but they don't necessarily, that's not necessarily inclusive. We're very, very concerned about entities. In fact, we're going to have a very big, specific definition for our entities here in just a second. But classes can actually contain other items, which is why they use the word things in their definition, the book does. All right. So entities are things that are in the domain of interest. Okay. We also want to describe the relationships between those things, which we naturally do whenever we think about information in an accounting information system. This is something that you've already articulated. We talked about it on Friday when we were in Excel. You probably didn't really think about it, but you said, all right, here are the items that we're looking at. What are the characteristics of those items? Like a characteristic of item number one is first name, Michael. A characteristic of item number one is last name, Barnes, okay? Those are going to be the attributes that we're going to be talking about, and then we're going to actually describe what the relationships are between these entities. Then we're going to specify how many instances of one entity can be related to another. This one's going to be a pretty tricky one. I will say this is an area that of mastery that's really, really challenging. But hopefully we'll do it at enough times at a slow enough pace that it'll become second nature. But this is a really important one. Being able to understand structure diagrams is really contingent on understanding these relationships, not just what the relationships are, but how the relationships are characterized on a quantitative basis. Then we're going to identify the attributes and characteristics and entities and relationships, as I alluded to before. So what we're going to be using for our tool in this course is going to be called Unified Modeling Language, which is UML, all right? So remember the object management group, they actually manage both BPMN and UML, and there's some overlap in the characteristics, which is nice. But for the most part, this is going to be the logical structure of a database system as opposed to how we interpret the structure of the database system as rational individuals. So it is going to look a lot different from BPMN notation, which is refreshing and also convoluted at the same time, because if I ask you to represent something both in BPMN notation and in UML notation, they're going to look radically different, because one is activity-based and one is entity-based. So this is, I think, where the confusion comes in, is that when I ask for one scenario, you have to say, all right, what are the attributes or what are the activities that comprise a particular process? And then when I ask you to do it in another scenario, you have to say, what are the entities or what are the classes that comprise the process? And those are not the same thing, as we're going to see. So what are the UML elements? We're going to talk about this in a bunch of different ways. When I get to a certain slide, I'm going to highlight that slide and I say, this is probably the most important anchor slide for you to focus on. So please make sure to make a note of that and then reference everything else that we talk about around that anchor slide. But that's, we'll talk about the elements first when we go to get that anchor slide. So the first thing we're going to talk about for UML elements represent classes. These are items about which the organization wants to collect and store information. Now we can actually represent these in multiple different ways, okay? We can actually have class name with the attributes and operations listed. So an example, this would be bank account with the account number, string, balance currency, and then the operations would be deposit and the withdrawal. Now, that's kind of a more complex version of a UML diagram that actually represents the class activities. I do think that this has some relevance, but I think it's going beyond the focus of what we want to do in this course. I would rather focus on the classes themselves than try to muddle that with the classes as well as the attributes and operations together. I think most of the attributes are fairly intuitive, and the operations are not necessary unless you're talking about a specific process, which then they become obvious because of the process nature. So class symbol with name only is usually what we're going to be using in this course. We are going to look at some examples here in just a little bit of class names with attributes and operations for the sole purpose of clarifying items that exist in UML diagrams. But all of our UML diagrams that we're going to create are going to be focused on single class symbol with name only, all right? So that's going to be a big relief because that's all you're responsible for. Now, here's one of the important things to talk about with what classes mean, okay? Classes can actually be representative of entities or things. That's something we talked about just a few slides ago. So what do I mean by entities? Entities are characterized by basically 3 accounting operations within a system, okay? Those are resources, events, and agents. In fact, you've probably heard, or you may hear if you read through our literature and information systems, you may hear these called REA diagrams. REA diagrams are resource event agent diagrams. They're basically the same thing as UML diagrams. It's just characterized by these 3 items. So resources are examples of items that are used as resources within an organization. So trucks, machines, buildings, cash, investments, inventory could count here. Basically anything that we consider to be a resource used for an exchange or a transaction. Then the events are going to be transactions that take place. The sales, purchases, cash disbursements, cash receipts are all examples of transactions. And then the agents are going to be, generally speaking, customers, employees. We could also include vendors here. Those are some examples of those. Those are going to be our primary items. Now, I want you to make a note. These first 3 items, these are what we classify as entities, all right? Earlier 2 slides ago, it said entities are things. These are our 3 entities. And these are going to be represented in every single UML diagram you look at. In fact, the very first thing that I will tell you when developing UML diagram is I will say, what is the resource? Or what are the resources? What are the events? What are the agents? That's going to be your step, is to first identify all resources, events, and agents. If you do that, it is a much simpler process than trying to muddle together a UML diagram just from basic knowledge. So if you walk through the first step and say, all right, I need to know what my entities are. What are my resources? What are my events or my agents? The one reason I mentioned that these are entities is because you notice there's a fourth item here. This is not an entity, but it still qualifies as a class, okay? So it's basically to speak forward, it's like say that all entities are classes within a UML diagram, but not all classes are not necessarily entities. The fourth type of item is going to be called a conceptual structure. So these are going to be accounts, product categories, budgets. This is anything, an additional item about which the entity wants to have information about. It does not qualify as an entity, but it is still a class. It's basically a relationship that we want to determine. We'll actually explain what that means here in just a second. It's not particularly difficult, but it is a little bit weird because it doesn't fall under the same entity hierarchy that we're going to be looking at here. All right, so here are our classes, okay? That's our first item. Pretty simple and straightforward. Generally speaking, they're going to be one of our three entities. Sometimes they'll be a conceptual structure. Next thing we're going to talk about are associations. These are just our relationships between the classes, okay? So this actually depicts what is happening between or two different entities within the diagram. So a person owns an automobile. So this line here from the person automobile represents the relationship between this particular class and this particular class right here, all right? An automobile is serviced by a dealer. Here's two more classes, or one class that we already knew about, but a different class in that relationship there. So we can characterize each of those arrows that are drawn between our classes, between our mostly our entities in there, and we can actually say, here's the relationship that exists. Everything, when we see a line between our UML diagrams, every single one of those lines should have some sort of characteristic or relationship. We can actually define what the relationship is between classes. If you see a line and you can't define that relationship, then it may be that there is no relationship and there should not be a line in the first place. All right. Next is going to be probably the most challenging one for this particular course. If you have some experience in this, great. If not, it's not difficult, but it is a little bit off-putting. Okay, these are multiplicities, and these represent the minimum and maximum number of times instances in one class can be associated with instances in another class. Okay, the really challenging thing about multiplicities is how to interpret multiplicities based on the way that they read. And usually a multiplicity is going to read the far, and class is going to read the far multiplicity. And I'll explain what I mean by that. So I want to characterize what the option for multiplicities are. So basically for multiplicities, there's four different possible options. So we can have an option for multiplicity. We can have 0 to 1, 0 or 0, a minimum of 0 by a maximum of 1, 1 only, 0 or more, or 1 or more. I think it's possible that you could have a 0 to 0 multiplicity as well. The only problem is that if it's a 0 to 0 multiplicity, there's no real relationship exists. So that's not really characterized, okay? So this is going to be probably what most of the times we're going to be looking at. I've also seen many to many, but that's very rare as well. Usually that doesn't come up. These are going to be what most of ours are going to be looking like. So how do we interpret the multiplicity? So let's think about, okay? A person can own 0 automobiles. There's probably somebody in this room who does not own a car, and that's cool. Okay, I didn't own a car in college either, but or we could have somebody who owns many automobiles. Okay, which I don't. There may be somebody in this room, not me. I have one car, who owns multiple automobiles, and if that's cool too. It gives you options for getting to campus. Okay, so a person can have 0 automobiles or many automobiles. So how do we interpret this? Okay. So a person has 0 automobiles or many automobiles. That's a possible relationship there. Now, this actually this is a depiction of what I was talking about before, is that a entity depicts the far multiplicity. So if I'm trying to determine what the relationship between person and auto is, I start with person, I go to the multiplicity on the far side, and then I interpret that according to what the other class is. Why they do that, I don't know. That's just kind of the UML diagramming rules. It's very confusing. But the earlier you learn to appreciate that and understand that, the easier it is. This is one of the areas that gets really confused on the exams. Then when I start saying depict this multiplicity, people naturally want to look at this multiplicity here and make this depiction. All right. If you say person has 1 automobile and only 1 automobile, okay, That's, first of all, that's not intuitively correct, but secondly, that's a wrong depiction of that multiplicity. So make sure that we go to the far multiplicity. Now, an automobile can be owned by one person and only one person. That's what this multiplicity is depicting, all right? And I guess you can make an argument that's not necessarily true if you're talking about some sort of relationship where some multiple people have ownership of a multiple bill. It's signed in multiple people's names. You could say it should be owned by one or many, but the way they depicted this multiplicity is saying 1 to 1. All right, that's just what this multiplicity interpretation is. So without getting into the whether or not this multiplicity is a correct interpretation, that's what this multiplicity interpretation represents. So if you're confused about multiplicities, this is a very simple way to interpret that. Come back to this slide and come back or go to it. Trust me when I say that we'll be doing this so many times that hopefully you'll have a good interpretation of that. But you have to make sure that you take this seriously. You have to make sure that you can read the multiplicity direction, because otherwise it becomes very, very challenging. All right. Then we're going to talk about attributes. These are going to be, again, implicit. It will not necessarily be outright stated in our UML diagrams, but we do need to be able to interpret them. So these are going to be the data elements that describe the characteristics of instances of class, which those are records. We already have familiarity with this in a non-UML context. This is our Excel file that we looked at on Friday, which actually shows you the the information about students. So I had 6 students in the class, and each of those attributes are different attributes that were common according across the students. Okay, they were different attributes or different values for each attribute, but they all had the same those attributes. So the full specification attributes, which would be listed in a data dictionary, would include data type, default values, constraints, and values, which would be minimums and maximums, and other descriptive information. For the most part, we were not going to include attributes in our UML diagrams directly, but the interpretation of UML diagrams will require understanding of what attributes exist. So even though the diagram itself will not contain attributes, you do need to know what the attributes are that are implicit to the classes that you're going to be representing in the UML diagram. All right. So a few other items. This one's going to be a reiteration of something that we've talked about before. But when we talk about UML elements, some things that we need to be able to define is we need to be able to define a primary key, which is an attribute, a combination of attributes that uniquely identifies a record. So a primary key is just basically something that we're using to identify something that no other value has or no other cannot be replicated through other values within the same table. So example, let's go back to this table here. Okay, which of these do you think would be a primary key in this particular table? A unique identifier for the item in this particular table. Yeah, banner ID, and that is actually your primary key here at Truman State. Every person in Truman State has a unique primary key. Okay. Now you might say, well, what if we had full name? Would that be a unique identifier? And the answer is not necessarily. I actually have had 2 students that had exactly the same first name and last name. The interesting thing is that one was male and one was female, so that was kind of an interesting little task right there. So yeah, banner ID is a unique identifier, and that would be something that we'd use to uniquely identify. So that's not something you necessarily identify by, but that's how I identify you in the system, is that we actually use that as a characteristic. Which when you're dealing with only 6 records is probably not that important, but when you're dealing with 6,000 records, probably a little bit more insistent. All right. So something important to note about a primary key is it cannot be blank. That really defeats the purpose of it. If it's blank, it can't be a unique identifier. It should be controlled so it doesn't change over time. So usually when we're talking about something like banner ID, it needs to be sufficiently large that if the population increases over time, they can adapt to that population increase. You guys have a 9-digit banner ID, if I remember correctly. We're still kind of in the, most everybody has 1 or 2 or 3 zeros beginning their banner ID. We're at the point where actually it's just 2 zeros at the beginning of banner ID, so we're in the tens of thousands. So they adapted it so it could be up to millions if you go that far. Which if we get millions of students at Truman State, well, that's going to be well past my lifetime. That's all I can say right there. All right. Additionally, we also need to be able to define attributes according to a foreign key. So this is an attribute, a combination of attributes that allow tables to be linked together. So this is an interesting one. And by the way, this may not make too much articulation sense in the context we're going to be talking today. We are going to study this in much more detail for relational databases. I don't know why I got stuck on that. Relational databases next week on Monday. So a foreign key is effectively just a primary key from another table or a combination of primary keys in another table. that we can utilize to develop a link between tables. So as we're going to see when we start looking at relational databases in the next week, this is basically using our putting an identifier in another table that's a primary key in another table, so we can actually combine two tables together and join information. All right. So some notes regarding primary key assignment. We're going to reflect upon this again next week. So should you use social security numbers as a primary key? The answer is no. There are legal restrictions. Not everybody has a social security number, so primary key, no. Not everybody, not every Truman student here at Truman State is from the United States. So some may not have social security numbers, which is cool. That's why we have our banner ID. Should you use people names as primary keys? No, names not unique. We talked about that earlier. Should you use phone numbers as primary keys? No, because those can change over time. Should you assign primary keys using sequential numbers? If possible, yes, okay? And this is a good idea because it's easier to identify gaps and we can control the numbers. This is actually a good policy for an information system because if you see gaps in the sequence, you can identify those gaps more equally and investigate why those gaps have occurred. So sequential assignment is actually a good best practices of policy for assigning primary keys. All right, we're going to talk more about primary keys next week. Right now, I want to keep that in mind. We are going to actually look at a problem on Wednesday, which I'll have to do some explanation on, but it will actually reflect very helpfully on what we're going to be doing next week when we talk about relational databases. Suffice to say, without primary keys, relational databases wouldn't exist, and without relational databases, we wouldn't have the advance in technology that we have today. So it's very, very important to have those items. So let's go ahead and look our basic UML presentation. This is for this course, all right? This is my anchor diagram. Remember, I alluded to this earlier. This is the one that I said, this is the really important one to note. And every question that you have about UML diagrams, start from this diagram and then reflect back on everything else. This is basically the level of complexity that you will need to know for this course, all right? So let's talk about this diagram because it's very, very simple and straightforward, but it contains a lot of important information that you need to have relevance. So you will notice this is a UML diagram for this actual class, okay? So what are the first thing that defines the class is that we have events. We have these every Monday, Wednesday, and Friday every week, okay? An AIS class session. The events are characterized by the resources that are used and by the agents who are involved. So the very first thing is we define the resources, events, and agents, usually starting with the event and then putting the resources and agents on either side. Every UML diagram you create should have this format. Resources on the left, events in the middle, agents on the right, all right? If you keep it that way, it makes things very, very clean and very, very easy to interpret. Now, what are the events of this class? An event is a class session like the one that you're in right now and me talking to you. That's an event, okay? What is the resources involved? It's information. It's what you're paying good money for, is information about accounting information systems. That's what you can sign up for. It says, okay, I'm going to be a business major. I really, really want to have that sweet AIS knowledge, okay? That's the information that you're getting. Here are the agents. There's two. There's me, okay? Or two categories, I should say. There's me, and there's you all, the instructors and the students, all right? What are the relationships here? We can actually see they're characterized by the multiplicities here. So in an AIS class session, I'm going to have a class session. If I have at least one piece of knowledge to share, I'm going to have one class session. But more likely, I'm going to share multiple pieces of knowledge to you. So at least one piece of information will be shared during class session, multiple, okay? And information will be shared at least one time in a class session, because if I don't have a class session, or if I don't have information, I won't share it. Okay, so information will be shared, but it can also be shared multiple times. Like, for example, primary key. I'm going to talk to you about that today. I'm also going to talk to you about that next Wednesday. So it can be shared multiple times. So it's kind of the interpretation of the class session, okay? All right, and then, so this is kind of the way the multiplicities work. Some of the multiplicities can be a little bit counterintuitive. Like, for example, you'll notice I have students involved in the AIS class session. It's possible that I could come here and nobody shows up. Everybody's just kind of like, okay, we are boycotting Dr. Barnes' class session. And it's never happened to me before, but you never know. As I get older, that slip of the tongue, and I could say something like I don't think the Chiefs are going to win the Super game, you know, and all of a sudden everybody's going to boycott. Yeah, hopefully they do. But if I accidentally slip the tongue and have that, then I could have everybody boycott, and that'd be a problem. Or, of course, more likely scenarios that many students will be involved in the AIS class session. Okay, that's the more likely scenario. Okay, there's a possibility that AIS class should be held, and I could forget to show up. As I get older, I start forgetting things. I'm not quite that bad yet. I've not missed a class yet, but I've had instructors who have, which has been really, really awkward because it's like they've been teaching for 20 years and they just forget to show up for a class session. Okay. We're gonna have multiple instructors that could show up for the class session. It could just be me, okay, then I could have somebody else that help me out here. So there's possibility there. That being said, AI's classroom will generally be hosted by one instructor or one instructor. So actually, there's multiple. I should teach multiple class sessions, not multiple instructors. But yeah, the class session is going to be taught by one and only one instructor. Yeah. So again, very simplistic, and obviously I made this one up. Okay, I made this one up just for the purposes of reinforcing this. We're going to look at some very basic examples of UML diagrams. There's going to get more complexity to this, but when I say more complexity, it's not going to be that we're going to be adding a whole lot more elements. That's not going to happen. What will happen is that we will add more classes to depict more processes, but they'll all be part of the same 3 columns and multiple rows, and there'll be relationships. For the most part, this is going to be your starting point, and your finishing point will be more classes added to the diagrams with more relationships. The good news is that the relationships are not that difficult to define. So as long as you understand the nature of the relationships in the classes, you should be in good shape. And you'll see what I mean when we get to the business process areas. Seeing multiple process areas, or seeing how multiple process areas interact, that's a pretty complex diagram. The good news is that I'm not going to make you go that far with respect to understanding. This is where you should be right now, is making sure and if this makes sense, if you're looking at it, say, okay, this seems intuitive to me, you're in good shape. Now, if you're looking at this and it's like saying, I don't understand any of this, then I would encourage you to leave the class after I'm done talking, go home, get on YouTube and rewatch the video to make sure that you understand it, because this is a really important starting point for this particular concept. All right. What we're going to be doing from this point forward is we're going to be talking about some conceptual stuff. Again, this is as complex as it's going to get for right now. And like I said, this is the anchoring point. Anything we talk about here, come back and refer to how we're going to look at this. I do want to go into a little bit more detailed notation of how UML diagramming works, but the diagramming we're going to look at is going to look different than this. This is what we're going to be using for this course. I just used some examples from other scenarios so I could actually look at more detail. So if you start panicking and say, okay, these classes look different than the ones Dr. Barnes was pointing out, these are the classes that you're going to be responsible for. Single item notation, okay? Whatever the class name is, and that's it. You don't have to provide attributes, you don't have to provide operations, but we are going to look at those so we can define what each of these items are, all right? So here's a class diagram example. This is what I'm going to say. This is more complex than I'm going to ask you to do, but I do want to make sure we can define what's contained within UML diagrams, okay? So usually speaking, when we talk about items that are in UML's class diagram, we want to actually be able to identify what is the nature of the class type. Now, the good news is, okay, that most of these are going to be defined for us based on where we place them within our UML diagram. So in that UML nightmare that I provided to you, you will notice that this doesn't have any rhyme or reason, which really, really bothers me, that you can't tell what's resources, what's events or agents. They have to be defined by these stereotypes up here. For our example, we're always going to characterize resources, events, or agents, okay? We are going to have another one. We're going to have conceptual structures, which we will talk about. But conceptual structures don't follow the paradigm, but we'll talk about where they fit in. Basically, they'll go wherever there's room. But for the most part, resource, events, or agents. So we don't necessarily need the stereotype because they're always going to be defined by where their placement is in the diagram. Now, class name assigns a name to the class item. That's actually something we need to note. That's important because we can't actually characterize what the relationships are if we don't know what the classes are. The class name is very important. Attributes describe the characteristics of each class. Attributes, again, are going to be implicit in our diagrams. We're not going to define them out. That being said, you do need to understand what possible attributes could exist for a particular class, because those are going to be the information that's shared in the relational database. And be able to define those are going to help us create our database associations. Associations depict the relationship between the class items. Again, sale of a good to a customer, okay? What is a relationship between these two classes or these two items that are listed here, right? So what happens with a customer and a sale? Usually you're going to have goods that are sold to a customer. So sale represents a transaction to a customer. Most of these are going to be fairly intuitive. These are going to be transactions you've looked at before. If you see an association between two classes that can't define that association, that's where you need to investigate and try to determine what this association represents. Like I said, primary keys used to identify records in each class item. You will notice that customer and sale both have unique primary keys. To that end, something that's not included in the slide is going to be foreign keys. Foreign keys will help us join this information. So say, for example, I wanted to be able to identify all sales to a given customer. I would probably want to include customer ID in the sales field as a foreign key. So that way I could actually pull up all information for customers. So basically I have two tables here. In the sale, I actually capture the information customer ID. That's part of the sales transaction that my database captures. What does that mean for me in the future? That means later on, if I look at a sale and I say, who was this sale to? I can actually say, all right, based on the customer ID, I can pull the name and the address of that customer. That's the beauty of relational databases, to be able to identify matching information. Again, we'll get into that more next week. That's why we have foreign keys associated with these as well. Those are going to be based on primary keys for a separate table. All right. And then multiplicities, these are associations. Again, these are fairly easy to interpret as long as you go in the right direction. Customer can be involved in zero sales because you can have a customer says, I'd like to do business with you, and they don't pass a credit check. So they don't engage in a transaction even though they try to engage, or they could have not yet engaged in a transaction. That's a possible interpretation as well. Many customers can be involved in, or customers can be involved in many sales. You got a repeat customer. Okay. Seabreeze Restaurant, which you guys are going to hear about. Is anybody familiar with Seabreeze Restaurant? Okay. You're gonna get very, very tired of me talking about it. It's my favorite restaurant. They're north of Kirksville. I eat there every week when they're open. They have been open for like the past few weeks. It's been a holiday break. But yeah, that's going to be one that's a multiple sale multiplicity for me because I'm there all the time. Okay. A sale involves one customer and only one customer. You only have one customer on a given transaction, and that's the maximum it is. So that's how we actually interpret the multiplicities here. All right, there's a few other items I'm noting for UML notation. By and large, these are just explanations for any additional information. You do not need to worry too much about this. I will say that 99% of the transactions, none of these notes will be relevant. But if you're confused about representation of the notation of the associations here, then you may want to refer to these additional notation items. Okay. So with that, that's pretty much our basis for UML notation. Now, there will be some examples in the homework. These are fairly easy interpretation examples. I don't want you to stress out too much about them. This is more at the beginner level, okay? But we do need to know these beginner tasks. Like I said, we're not going to be doing anything too much more difficult than this right here. In fact, I would tell you right now, probably what you could do is you could do a screen capture of this. You could wipe out the words that I put in here. You can just blank those out, blank out the multiplicities, and you can use this diagram for your homework, because I believe that this is actually the same representation for the classes, or all the classes that are in your homework assignment. And I will tell you that's something that I do is I tend to manipulate whenever I create UML diagrams. I tend to manipulate existing images, and I use them in subsequent images. So that's just a little trick. You can also create these using tools. If you know how to use Microsoft Visio, that's a very easy way to do it. You can create these in Excel as well. They have object implementations as well. If you want to do it by hand, that is absolutely fine too. There's no justification for doing any way other than what you prefer to do, as long as I can read it and grade your homework. All right. To wrap up, we need to talk very quickly about rules for decision making. Okay, so these are going to be relevant to how we actually depict our processes a little bit later on in this course. Okay. So decision making is going to be characterized by the risks that are associated with the organization and the rules that we have to implement with respect to those risks. All right. So analysts must recognize decision-making requirements and establish business rules to support those requirements. So we have 4 steps in the decision-making, in establishing decision-making requirements. First of all, identify the decisions required in the process. Can't really answer any questions unless we understand what decisions we need to make. Next, we have to describe and document these decisions and how they impact the business objectives for the process. Now, you can basically shorthand notation this particular step as saying we need to document everything with respect to the decisions. If we don't document it, then we can't actually move forward with the process because we don't know what the decisions will be. Then we specify decision requirements in terms of the information and knowledge required to make the decision. What does this mean? This is basically saying that once we've decided upon what decisions we need to make and how we're going to document those, then we're going to say, what do we need? What information do we need? What knowledge that we don't currently possess do we need to be able to implement the results that we need to for these decisions? And then finally, decompose and refine the requirements, determining where existing business rules apply and where new business rules need to be developed. We're going to look at this in a lot more detail once we get to our chapters, start talking about controls. But the process is an ever-evolving process. So we don't just make a decision one time and say, okay, we've done that. We can move forward from here to eternity. Times will change, risks will change. So we need to be able to adapt and update these decisions as necessary as things change. All right. So what are some business rules? What are some business rules that we need to be able to define in order to be able to understand what it is we're going to be doing? So We're going to talk about three general categories of business rules, and some of these are going to be mirror reflections of another. They are pretty straightforward. The interpretation is not difficult, and they're probably the way that you would characterize rules in your own environment. So the first type is going to be called an obligatory rule, and this just basically says this is what should occur, all right? So an example of this is that payment should be made in US dollars. This is a requirement for a particular transaction to take place. Now, the flip side of that is going to be a prohibition or a prohibited rule. This states what should not occur, all right? So instead of saying what should happen, we say what should not happen. Basically, the interpretation for a prohibited rule is as long as you don't violate the prohibition, other actions are possible. So if say no payments by check, the answer should be, okay, if there's no payments by check, are those going to be allowed for cash or credit cards, okay? As long as payments made in US dollars, there's no real specification as to how the payment's made. I guess you could make the argument, okay, that means that we could use cryptocurrency too. It would really depend on the parameters. That would probably require a more defined obligatory rule in this situation. But by all means of interpretation, a prohibited rule basically say this is something that cannot take place. And then the allowed rule says this is what allowed is under certain circumstances, okay? Credit card payments are allowed if the card is American Express. So as you can see here, basically we have payments made in US dollars. That's our obligatory rule. Prohibited rule says no payments by check. So the interpretation of the allowed rule is saying, assuming that we understand what is allowed and what we should and should not do, we need to understand what is allowed and under what conditions that's going to be allowed, okay? And this is a really weird one, simply because I've never seen a company say that credit card payments are allowed if it's American Express. Usually most companies say no American Express, but that's what me, I like to be contrary in my slides. So as far as the way a decision table is going to consist, this is going to be fairly intuitive. We actually need to define the name of what the decision is that we're going to be associated with. What are the inputs? What are the outputs? And what are the rules, okay? So the inputs are actually going to go in the same area as the table as the outputs, but they actually define what's going to the outputs are going to be. So easy example of this is that we're talking about how do discounts apply in a particular scenario. Well, we've got three rules associated with them, and they're going to be contingent on what is the customer type and the size of the order. For business rules, then basically any order that's less than 10 items is going to get a 10% discount offered. If it's greater than 10, then you get a 50% discount, but all individual transactions only get a 5% discount. So that's how we would interpret those. I will tell you, I have not traditionally asked about decision table rules in my exams. I do think that these are somewhat difficult to interpret, especially if you get past, for every additional rule, it gets extensively more difficult to interpret. So three rules are pretty straightforward, but if you get to like 10 rules, it can get really, really challenging. So I would be familiar with this, but don't worry that you're going to have to replicate a business rules diagram, because I traditionally have not asked this. That being said, you do need to be able to dictate what types of business rules exist. Three categories of rules for decision making. This will become particularly important because we're going to talk about business rules as they characterize internal controls later on in this course. And internal controls, as you already know, are one of my favorite things to talk about, but they're going to dictate the parameters, that are constraints that are within the system. All right, and with that, we are done for today. We will have our first NetSuite session on Wednesday, as well as our homework review after we get done with the NetSuite. So please make sure you complete your homework, submit that before class. So we'll see you on Wednesday.